Пожалуйста, панелисты.
Well, let's continue with our conference. And so the second session begins. I am pleased to give the floor to Alexander Panov from Gazprom Neft, who will share their views on reliability digitalization. Mr. Panov, you have the floor. Andrei, greetings. I greet all the participants of our conference from the sunny city of St. Petersburg. I'd like to share our experience with all the participants to tell you what we managed to do in the production asset reliability, what we are doing, what our plans are, and what tasks we have. The department I run is engaged in efficiency improvement. Next slide, please. To manage reliability, we first consider the balance between costs and risks on the one hand and the required asset performance on the other. To achieve the maximum effect in our company, we consider all stages of the equipment life cycle using a risk-based approach. It's worth nothing that it took us a great deal of time. We had to go through a lot of experience and a long phase to come to the appropriate level of competence and understanding of the target state of reliability management. Next slide, please. The intensive development of the reliability management system in the division started in 2017. Here I will show you history from 2017, when our corporate center made this functionality a separate focus area. During this period, the Performance Management Center was established. And it was in the center that we have a special unit dealing with reliability management. At the moment, we started up the monitoring of critical deviations along the entire value chain, and our specialists began to develop a risk-based reliability management methodology for our refineries. In 2020, we began and have now completed drawing up a technical policy of asset reliability improvement. It describes uniform requirements to equipment maintenance and reliability not only at the refineries but also at all subsidiaries that are in the perimeter of our division. Much, let's say, painstaking work was required to write this technical policy, but today we already have the final version of the document. In parallel, we began to build business processes. Today, we are actively working on the development of reliability management systems and conducting performance analysis using balanced key performance indicators. In the future, we are planning to expand the existing functionality and establish an asset reliability management center. The main tasks of the center will be to ensure compliance with the uniform principles of the technical policy and the methodology requirements at all stages of the asset life cycle, to design and develop a reliability management system for the downstream division, analysis, goal setting, and performance improvement of the reliability management system. There is another important element that we have developed and apply as a quality tool. It's a constant search for the best practices not only within our company but across our industry. Next slide, please. For the comprehensive approach development, we set ourselves the following goals that directly affect the efficiency of the facility operation. These are improvement of industrial and environmental safety, enhancement of asset operational availability, and reduction in the cost for maintenance and repair. To achieve these goals, we have developed a target model for managing business processes, and we are updating it as a part of the development of our competencies in reliability management. The transformation of business processes cannot be realized without the transformation of the organizational structure. Therefore, attention and evaluation and the importance of the organizational structure directly affect the quality of reliability management. That's why we are currently developing a target model of the organizational structure of assets, which will allow us to effectively manage the processes related to the improvement of reliability and maintenance of the equipment. And another key task in the implementation of the comprehensive approach is the development of IT tools that help to automate reliability and maintenance management process. The solutions implemented have already proved their effectiveness. But today we have an understanding that these solutions have additional potential. We are constantly working, meeting with companies that offer us solutions to raise the automation using more advanced tools. And we are also developing the functionality of the existing systems, such as Satura and Meridium. Once again, I'd like to emphasize what the comprehensiveness of our approach is. That is the solution to three main tasks. These are the target business processes, the organizational structure for the business processes, and the tools that support these business processes. Next slide, please. While implementing the comprehensive approach, we are guided by specific principles when building a reliability management model. This allows us to ensure the manageability and transparency of the implemented business processes. What these principles are? They are unified requirements and approaches to reliability assurance in the division. Asset reliability management throughout the life cycle, which is very important. Also, end-to-end cross-functional reliability management processes, systems of balance key indicators for managing reliability and maintenance efficiency, and 100% standardization of asset management procedures. Next slide, please. The architecture of the target operating model of business processes is developed based on the PDCA cycle. This approach allows us to improve our business processes. Next slide, please. When transforming the organizational structure, we were guided by the principles that allow us to improve the efficiency of the processes in the short term and lay down the potential to increase the industrial and environmental safety of the operation of processing facilities in the medium and long term. Next slide, please. The development and replication of IT systems based on advanced technologies is a key task when building a comprehensive approach. In today's environment, you cannot build a complete reliability system without having automated maintenance and reliability management systems. These tools are rapidly developing all over the world. As I said before, there are a lot of offers on the market today that can bring you to a whole new level. And this wide choice of solutions has determined for us a certain strategy for further moves. First, today, those systems that have already been implemented on our assets. These are Satura and 1C, and we continue to expand and improve them. We also use such tools as Meridium. We also plan to develop it. At the same time, today we focus on the use of tools that forecast, predict possible equipment failures, and so-called predictive analytics. These are fundamental systems that you, Andrei, are engaged in, diagnostic and monitoring systems that are the basic sources of information. And today we have a certain portfolio of these solutions, which we are implementing through a specially created program called the Reliability Management Program. Today, the tools that have already been implemented or tested bring tangible results. And even though we have not yet fully utilized the entire range of tools, even at this stage, they allow us to optimize costs for repair and maintenance and the like. Next slide, please. This slide presents our target vision of reliability management in our company, the implementation of which will allow us to seamlessly apply the developed methods to improve reliability and effective principles of maintenance and repair management. The system of analytics and the system of key indicators allow us to determine the areas of the development and find the optimal approaches to reliability management. My speech is over. I'm ready to answer questions and listen to suggestions. Thank you very much. I'm announcing the next speaker, Maxim Lenkov from Sibur. Unfortunately, due to certain circumstances, he was unable to attend in person, so I'll now present a video record of his report. Good day, dear colleagues. Today I'd like to talk about condition-based maintenance. Why is it important? Why do I want to talk about that of all things? Because we all strive for safe operation of our machinery, and at the same time for the way to reduce costs for maintenance. There are many ways of doing that, lots of strategies. One of those strategies is, in fact, transition from preventive maintenance to condition-based maintenance. What is a condition-based maintenance? It's not only getting rid of scheduled maintenance and repairs, it's the strategy of machinery maintenance that allows detecting a defect at an early stage of its development and perform corrective maintenance actions to achieve safe, faultless operation. Condition-based maintenance requires expertise from your personnel and mature processes, and also technologies that would help you to detect defects at an early stage. And the most important thing is to be able to determine the exact moment when the defect has just appeared and prevent the accident. On the diagram, you can see that condition-based maintenance is only one step in the evolutionary path of the company's asset management. Here you can see that we have started from passive reaction maintenance, then, as a lean production system was developed and a risk-oriented approach was introduced into the maintenance procedures, we moved from failure-based maintenance to reaction maintenance to the point when we don't want to wait for the failure to happen. Our goal is to move to proactive maintenance, where we would have to battle defects only. Our next step is incorporating preventive diagnostics using big data and other tools, including digital tools, in order to achieve our goal. What is moving to condition-based maintenance in terms of numbers? After we interviewed our experts from foreign companies, we saw that moving to condition-based maintenance would allow us to reach better performance efficiency by 10% in average. Also to reduce maintenance costs and increase the machinery service life by 20 to 40%. Once again, those numbers are provided by experts. How does it look from the perspective of unscheduled maintenance? If we take rotating machinery as an example, because it's very important, because when you introduce new maintenance strategies, you want as few failures as possible. So, as we can see from the diagram, when we switched to condition-based maintenance, we reduced the number of failures in 4 years by 50%. This information is anonymized, but that's what the statistics shows us. Why the condition-based maintenance is so important for a company? Sure, as a business company, we can see the economic effect that we obtained by implementing this strategy, including better performance. Our company actively uses different performance-boosting tools, such as choosing better actions in accordance with the risk-oriented approach based on the risk analysis, adjusting time frames for each action through motion study and personal training, additional equipping of maintenance shops with modern diagnostic and maintenance instruments and tools, and implementing new initiatives as a part of the digitalization project. I'm going to talk about that one later. As I said before, the estimated economical effect is fewer man-hours, but also moving to CBM will result in more inspections, up to 30%, but to fewer scheduled preventive maintenance tasks, up to 20%. And as a result, as I said before, we achieve better performance of the maintenance staff, up to 5–10%. If we take our company as the example, we saw how the global companies struggle with the current situation at one of our plants where we switched to this new maintenance strategy. The number of failures at machinery switched to CBM at one of our plants. In a few years, we predict that it will reduce roughly by 44%. That's quite a good number. I'm pretty sure we're gonna reach it. Why are we so sure that moving to CBM would improve the reliability and wouldn't cause more failures? First of all, right now we use CBM with machinery with a low criticality rating. And for each piece of machinery, we assign its risk level. In order to do that, we developed our corporate standard. We make assessment of each piece of machinery by two aspects: consequences and probability. And the following issues are considered: safety, environmental impact, maintenance, production losses, effect for clients. As a result, we can divide all the machinery into 4 basic groups. You can see the example of the risk matrix on this slide. And the machinery with lower criticality ratings we consider for switching to CBM. For that purposes, we use the system called Meridium, which uses algorithms for determining an optimal maintenance strategy. The basic algorithm is determining types of failures for each component of a machine. Then, for each failure, we determine its model, characteristics, and effects, and then we choose the best maintenance strategy for failure prevention. To actually follow those recommendations in terms of moving to CBM, we have to perform more inspections and diagnostics of machinery state. In order to find the right maintenance strategy, Meridium also uses such instruments as a decision tree. The basic strategy selection in accordance with the decision tree, a machinery specialist has to answer the given questions to make a decision. That helps them to find the best maintenance strategy. As I said before about the inspections, how do we make those, and which instruments do we use? On the right side on the slide, you can see the different instruments, such as mobile checkups that let us to detect machinery defects at an early stage. Next, it's Preventive Diagnostics, a remote expert based on augmented reality, which means we can discuss the found defects with the machinery vendors without bringing it directly to them. And also vibration diagnostic systems, such as Compax and Signal One and to Bradley. When used together with other tools, this instrument can ensure us that machinery switched to CBM will not fail, will not cause any losses, and is gonna be safe. What's next? And next, as we stabilize the effects obtained from this machinery of the 4th and 3rd groups of criticality, we are going to develop new strategies for the machinery of the 2nd criticality group. But that's the matter for the future. So for now, I'd like to finish my presentation. Have a good day, everyone. Thank you. I give the floor to Vitaly Izak from Kazmunai Gas, who will give us their vision of reliability, digitalization, and management. Vitaly, you have the floor.
Greetings everyone, thank you for the opportunity to take part in this conference. Thank the hosts. While the presentation is launching, I will briefly say that in the presentation I would like to provide insights into our experience of implementing the risk-based managing without deep immersion, but I think it will be interesting. We will tell our approaches, future plans, our way up, what we should pay attention to, what difficulties we faced during the implementation. I think a lot of people had them. Let's start. I represent the company Kazmunai Gas, Kazakhstan, the oil refining unit directly, and would like to share my experience implementing the risk-based approach to managing equipment reliability and integrity. Next slide, please. We will briefly go through the strategies and history. I will show an example of how we moved to the risk assessment system, the metrics, the outcomes from the use of Compax system. We surely have them. We have something to show you. We will also highlight the problem of our legislation as well as further steps regarding the working interface. So there is a brief information. If someone is interested, you can look through it later. Get acquainted. Please, next slide. On this slide, I would like to show the strategy. This is a direct transition to an effective system of planning, the preparation of repairs, creating a single unified risk-oriented system for managing assets maintenance and reliability at our plants, the transformation and digitalization of the asset maintenance and reliability management processes and the reliability of manufactured assets, and the efficient use of company finances for maintenance without compromising the equipment's safety and availability. We have set the following goals. The first one, increase the overhaul interval and change the repair cycle structure at Kazakhstan's refineries. The second, reduce the production risks and increase the predictability of the equipment health. The third, introduce a sustainable operational rhythm at refineries and petrochemical plants, effective processes and techniques for preparing and implementing shutdown maintenance, improve reliability and reduce unscheduled downtime, pass from preventive maintenance to a risk-oriented system of condition-based maintenance and repair. We've also got a goal to create a centralized system of vertically integrated management of asset maintenance and reliability. Next slide, please. It's worth noting the main trends in the management of physical asset maintenance and reliability. One cannot mention the technologies without mentioning people. Here we always focus on people. What we are doing in this direction, we organize a system of theoretical and practical training and support in the workplace. Here we use such methodologists as representatives of Canada and company RLG, the Russian company Maintex, and a part of IBM and, of course, Honeywell. We have implemented courses to improve the technical literacy of operational staff. One of our enterprises is currently implementing its own training center, which will train employees, improve their literacy in the management service, reliability in digital solutions, taking into account new business processes. We unified the organizational management structure where we learned the practices of Honeywell. They acted as consultants. We adapted it, partially changed it, but nevertheless unification happened. In terms of performance management, there are obviously metrics and the efficiency system. In terms of technology, we are also implementing projects on computer simulators because its operation also significantly affects the reliability of equipment. The system of preparation and carrying out repairs has given its results. It's supposed that the planning of repair should begin months before the event. There are certain tools and practices. We went to Singapore, got acquainted with how they get used to Singapore Refining Company, exchanged experience, no way around it. We also developed a business process for the maintenance of reliability management as part of the digital transformation of the Kazakhstan National Fund, and use the ARIS software product for such simulations. The issue of standardization and the development of the unified codes and standards, including the classifier of inventory items, is also important. Later on, I will briefly draw your attention to this. Regarding technology, we have automated the processes of maintenance, repair, and reliability of equipment and mechanical integrity management. Here we have applied the knowledge, experience, and the skills of Honeywell. They have their own production facilities, their own factories, so we used their experience. We applied digital solution of IBM Maxima, Meridian APM, and Asset Central in terms of accounting for downtime, calculating indicators. Also, we applied real-time monitoring of equipment condition via Asset Central, which is integrated with my system. Moreover, when we integrate the signals of the compact system at some enterprises, we have partially installed a DMR and other systems. This is briefly about the main directions of development. Next slide, please. On this slide, I want to present our path. It's not described here fully, but there's the main milestones that we have had since 2014. We have currently developing and moving on. At the preparatory stage, we performed an independent equipment condition audit for the refinery's transition to an extended overhaul period, developed a preliminary national standard for extended overhaul cycle of operation, since the Volgograd regulations from the 1987 on the plant preventive maintenance were previously in force. We developed specifications regulating inventory levels, about 12 standards. Now they have become the state standards. Based on the results of the audit, we developed programs for the replacement of critical equipment units, pipelines, and implemented them. In the period of 2017 and beyond, we moved to the introduction of digital solutions, developed and modeled business progresses, were engaged in the unification of organizational structures, also conducted systematic theoretical and practical training of employees in new processes and solutions. We also introduced a single unified classifier. In 2019, we completed the process of implementing the classifiers. We are currently in the process of summarizing the database. I will not talk in details about ISO 14224. I suppose everyone knows it. The asset register is being formed. It's impossible to say that someone has formed it at 100% because the depth is equal to the quality of the source data. And this is a continuous process of improvement, since assets are changing. Their depth is constantly improving with the growth of the company's maturity level. We also engaged in changing the industry, regulatory and legal acts of the state pressure equipment safety regulations. It's designed for the entire industry and limits us. Further, I will briefly talk about this. Next slide, please. As for the unified classifier, in fact, this is a sustained effort, and personally, in my opinion, this is about 20% of the transition to digitalization of repair processes and reliability. It's impossible to implement solutions without perception of the regulatory and reference information. What we have done within this project: we have made up a classifier and a reference book, developed a system of classification and coding of functional locations and equipment items. There is a tree-like structure of the basic classifier, templates for a class or subclass, group or subgroup of nomenclatures, indicating the properties and their values. We have developed the regulations for filling in classifier and reference book of inventory items. According to the result of data collection at 3 refineries, reference books were obtained. In total, we have more than 100,000 of the duration of the audit. When we evaluated warehouses and existing directories, there were more than 100,000 nomenclatures when they were brought to a single name. Then we have about 18,000 unified nomenclatures left. That is, the duplication and quality of the original data presented numerous times. Below we listed the groups into which the classifier was divided. Next slide, please. Previously, I emphasized that the processes are a very important thing, and here is, with the assistance of our Canadian colleagues, created a project to introduce a new full repair management process. It consists of 3 main areas: planning, optimization, and performing. At the planning stages, we carry out diagnostics, evaluation, and analysis of current situations, then build the process and KPIs, assess scope of work. After the evaluation, we develop the unified schedules, guns, resources, sites, and materials. The optimization stage performs its theoretical maximum. On this step, we interact directly with the performers. In other words, there is a norm of estimated time of labor cost of 2 types: actual norms and the one where the schedules and critical ways are discussed with the performer. In most cases, there is optimization and perspective to reduce the planned repair time without any losses of quality and the scope of work performed. The next step is performing. There is operational rhythm. The matrix structure at the time of repair are developed. They are divided into working groups: repair management, general staff, with the attendance of the CEO. The jobs are planned and final meetings are conducted when the work is done. There are discussed the points which should be emphasized in subsequent period in order to improve planning. The following offers achieved improvements in the project. It was implemented at 2 plants. There are such points as scheduling process, work execution process, procurement process. The entire plant is focused on timely, high-quality completion of repairs. The following slide, please. On this slide, I want to show you the architecture of digital solutions that we have applied on the basis of the existing SAP ERP one as Enterprise Management System, MES Automated Process Control Systems, and within the framework of the Programs for Technical Audit of Critical Equipment, we applied CompactSM. The systems implemented and their interaction is shown at the top level here. We have implemented the IBM Maximal system, which is a system for management equipment maintenance and repair. Meridian APM, an equipment reliability and inspection management system. Asset Sentinel, an equipment database monitoring system and downtime report some function, an equipment downtime event efficiency accounting system, and a KPI analysis accounting system. Currently, we are implementing such solutions as a digital 3D master plan, not simply a model but a master plan. We carry out laser scanning, processing of desk data with an accuracy of up to 10 mm. The 3D master plan is integrated into Idea Maxima and tied to assets so that you could visually see the asset when you work in the system. There are a number of other qualitative parameters and effects. We continue to implement analytical systems of equipment condition monitoring new processing units. I call them so because the currently used CompactSM system may not be applied only for vibro diagnostics. We also applied it to statics, so I use such term. A brief functional is presented below. Not all of it listed, but the main one. I will briefly run through Maximo. It helps us with daily maintenance management, planning and scheduling, preventive maintenance management. This is, by the way, a complex graphical planning module that soon will be mastered. It replaces the Primavera and the project. We use the latest version of Maximo, 100% of its functionality implemented. Here is also an option of personal qualification, procurement of spare parts and contractor services, and material storage management. We also use the system that provides such functions as time counters and monitoring, historical data, accounting for downtime, the module that I mentioned, production losses, analysis of reliability and process problems to improve the overall efficiency of equipment. Let's just say that the overall efficiency of the equipment is a complex but fundamental indicator. We are still setting it up, but we ensure that it works with high-quality source data. I suppose it makes no sense to present Meridian NPM. Everyone's already known it. Next slide, please. Perhaps not all attendees know what a reliability management cycle is. I would like to tell you how to use it, but it's probably the same for everyone. We identify problem equipment, conduct a risk-based criticality analysis, and apply the RCM, FMECA, and RBI methods depending on the criticality. Based on this, we develop maintenance and repair strategies, and then there is always an analysis of the effectiveness and quality of the strategy implementation. Next slide, please. Here, I would like to present the risk metrics developed by Maintix according to the SAE standard J81012, Method Service Vehicle Aerospace Recommended Practice Guide to the Reliability Centered Maintenance Standard. We defined risk as a combination of the frequency and consequences or severity of the event. From the business point of view, the risk is classified according to the following indicators: by risk rank, safety, environmental production, and by financial risks, possible production losses. Here, I would like to share my personal opinion, ironical perhaps, but they calculate their financial benefits from the implementation, and projects from the similar ones we can show justify the results. However, in fact, there are only two consequences from a business point of view: cost reduction and increased profitability. All other indicators only show how to achieve this. I think that there is not one of the safest and the most unprofitable in the world. Therefore, it's all about reducing costs, increasing income, and as my colleague said earlier, there should be a balance. And the more it is, the better. The next slide, please. This is an example of a Terao plant. I would like to show you how these interfaces look like, how systems look like in the Meridian system, how the criticality is determined, the current status of the data. We follow the path of the initial division of installation into systems, determine the criticality rank of the system, and then in ranks we determine the types of critical equipment. This allows you to optimize the time when performing an analysis of the criticality of the equipment. Next slide, please. Using the example of one of the factories, of course we cannot show financial indicators, but we can show qualitative and quantitative ones. Since 2006, we have been cooperating with your company, and for 2020 we have achieved these results. The fact at the plant we left the system for scheduled preventive maintenance and switched to the condition-based maintenance. This is all of dynamic equipment. A screenshot of the workstation is also attached here. It's also equipped with a static equipment. On average, it's reduced by 3 times from compared to the scheduled preventive maintenance, while the failure rate does not increase. This is a good indicator of the effectiveness of these solutions. Next slide, please. When we talk about reliability, we are not only talking about equipment and people, but also about technology, its impact, and the consequences of processes on the mechanical integrity of equipment. In this direction, we are now implementing online corrosion monitoring on the case of the Pavlodar oil chemistry refinery. The company that implemented them is mentioned here. We install the sensors to critical equipment, and at the moment we are processing the data. The measurement points are shown below. On the right, we see the applied solutions and devices. Next slide, please. We have developed dashboards for monitoring corrosive agents in raw materials in petroleum products. This is the case study of Pavlodar oil chemistry refinery. Information dashboards are developed in MES and simultaneously display data on the screen in the central remote control room. Here we see the mass fractions of water in the components, boiler fuel, the content of sulfur, water, nitrogen in hydrogenators as a percentage. This dashboard have key indicators. This allows to control the work to stand responsible person during operation at the pre-trial stage, and also pursues these increases in reliability and reduction of aggressiveness. Next slide, please. On this slide, I show our big issue that we have faced in our online. These are industry rules that we are regulated by our law and set requirements for the entire industry, for those who operate pressure vessels. I think there were similar restrictions in Russia in a certain stage too. In order to check the rate of corrosion and conduct inspections, they require stopping the equipment. But after 4 years, the Ministry of Emergency Situation has understood the difficulties we face, and this year, in the 4th quarter, we are expecting changes that will functionally allow us to apply processes such as NBI analysis and form inspection schedules based on risk factors, which in the future will be able to help increase the repair intervals in these certain cases. Next slide, please. The further steps of development. We are not stopping, we are moving, in some cases in parallel, in some cases sequentially, but always in the direction of improvement. We are integrating maxima with the master plan. This is a laser model, the most accurate. We are engaged in the development of mobile maintenance Taro systems now. The plans include the development of instruments calibration management in Meridian system, setting up the maintenance and repair management for line assets in IBM Maxima Linear Asset Manager. This is a large separate layer. So far, I haven't seen that this is well developed. This applies specifically to the management of repairs of pipelines, power lines, railways, highways, all assets of a linear physical structure. Completion of FMECA and RCM analysis on high-risk equipment. Centralization of digital solutions. Here we clearly understand that Asset Answers product is all about the reliability analysis. While we cannot implement it on this platform, We do it on the ClickView platform. We continue to equip critical locations with analytical monitoring systems. This is our long-term plan. We adhere to it, and we are moving in this direction. Next slide, please. This is it. Thank you for your attention. I will be ready to answer your questions at the end of this section.
Если что-то было интересно или вопросы какие-то есть, я потом готов буду ответить на это. Спасибо.
Спасибо. Спасибо большое, Виталий.
Thank you. Thank you very much, Vitaly. Now I ask each of you to answer this question. What is being done in the world, or to be more precise, what tools do Gazprom Neft and Kazmunaygaz use to digitalize the reliability of instrumentation and control systems? We talked about fixed equipment and also mentioned rotating equipment. As for the instrumentation and control equipment, do you have any thoughts? Alexander? Andres, thank you for the question. What I'd like to say is, in response, is first of all, we are now installing sensors that all have self-diagnostics. This is a very important element that online efficiently and quickly determines the condition of primary instruments located directly in the field. This is one element. The second element, and Vitaly already talked about it, and if I remember correctly, the previous speaker from Sibur also spoke about it, I mean mobile checkups that we already use for our instrumentation. It's when people perform an in-field maintenance using a mobile device. During a checkup, the checklist must be filled in, which confirms that the locksmith or some other employee has performed some field work using a mobile device. This is also an element of digitalization. And this one part. But I'd like to add a little more to the other part. It has to do with the automatic process control system. I believe that it's a part of the instrumentation and control. Today we are implementing digital solutions that allow the operator to make decisions, or the so-called digital prompters. These are the first prompters, and the second prompters are the fully automated startup and shutdown in different situations. We elaborate all these algorithms, plus we use artificial intelligence in some part of the process, which assists the operators. And we have now conducted such tests at our facilities and have seen a higher added value from the increased safety. Human factor mitigation is also one of the digitalization tools that we are replicating all process facilities of our refineries. That's probably all. Vitaly, could you also add something? Colleagues, clear up the question. You said that you are analyzing instrumentation and control systems in Meridian. What can you say from this point of view?
We have a technical and qualitative KPI in digitalization, including the time of repairs, operating time for failure. The fundamental one is the overall efficiency of the equipment. Based on this, our top managers are already making decisions on investments and development of individual installations. This is the basis. I participated in conferences and watched reports on reliability, and they are quite identical. There are also gold standards for efficiency. It all depends on the decisions, what that business want to be focused on. It all depends on the decisions, what that the business wants to be focused on. Every plant has different indicators, but the main ones are still the same.
Okay, thanks. Thank you, Vitaly. Question to Vitaly again. Is it possible to apply the RBI strategy to extend equipment life?
The extension must be handled by a special credential organization. In our case, as I have already said, there are restrictions on the regulatory field, so we are currently limited. In general, we can increase the interval between inspections, but extending the service life of the equipment is a little different. In our case, when the vessel has worked out in the estimated service life, we are obliged to involve a special credential organization that performs calculations for the remaining service life. When they perform the calculation, when they say, conditionally the vessel will work for 8 years, We are currently limited by the rules. Depending on the corrosion rate, it's necessary to stop the machine once a year for technical inspection. If the rate is less than 0.1%, then every 2 years. In this case, the RBI allows determine the frequency of technical service in the estimated residual resource. But I don't think that RBI can calculate the remaining term software on the legislative basis.
Okay, thanks. Now, Alexander, a question for you. Alexander Panov spoke about 100% standardization in the management and control of asset reliability. Can we say that the complex is a part of these standards, or is it a general approach? This is not exactly what I was talking about. In general, the complex is a tool that allows us to assess the equipment's condition. I focused on that, but I'll say it again. First, we developed a common technical policy. That is a set of uniform rules, or as we call it, the technical constitution for our entire division. This is the first point. The second point is that the further comprehensive development of all the business processes that cover the entire life cycle and all the participants involved in reliability management. And the third point, which I spoke about already, is 100% coverage of those business processes that must be strictly standardized and have standards, regulations, and specifications. And the complex is one of the tools that does not lie in the business process because it's just a tool. Because complex is something else. I'd also like to comment on RBI. Indeed, today it's not enshrined in law. Those tools that we use today, RBI, RCM, and the like, must be legislated. Vitaly told us about their experience in amending standards in Kazakhstan. And it's a topical issue. I just wanted to say that we are now also considering the possibility of legislating the transition to a time between overhauls of 5 or 6 years. That is to go a little further, and so far we have not taken this step. But we have such plans. And we would also study the experience of Kazakhstan, and maybe it would be useful for us. Yes, I want to join the discussion. This is a very interesting question, because Alexander was one of the first in the world who raised this issue when he was in charge of the aromatics production center. At that time, we carried out this joint work with Rostechnadzor, and we managed to get approval for the condition-based maintenance of equipment when permanently installed health monitoring systems available. But then Rostechnadzor's policy changed in this regard, and everything fell back to square one. So you have lots of experience, Alexander. Okay, let's move on. There are lots of questions, and I'm very glad. Question to Vitaly. Good afternoon. If a piece of equipment, let's say a pump, is not equipped with a permanently installed monitoring system, what maintenance approach do you use?
Here I say that it doesn't depend on the equipment of the pump if we consider it with some systems. It's more affected by the criticality of this position, the technical place according to the metrics that we showed, and the rank of the impact of its failure on production, ecology and safety. It's highly critical, and we still leave the maximum set of actions related to the manuals of manufacturers and technical passports, but the emphasis is on how much it allows you to operate it flawlessly in a given period of time. If there are any failures, we certainly try to change the actions, perhaps even in terms of the quality of the materials used. We even apply, as it was in the case of mechanical seals, their so-called free equipment. We change the basic seals to a more updated one.
Okay, thank you. The next question is for both of you. So I'm going to ask Alexander to start, and Vitaly will continue. Hello, how do you prolong the turnaround interval for non-spared machines? What systems do you use? Is it possible to increase runtime? A very good and correct question. Of course, non-spared machines have the highly critical status. The actions we take are the following. According to our policy and all our requirements, all highly critical equipment must be equipped with diagnostics and monitoring systems. It's a mandatory condition, it's a basic requirement. But it's not enough today, because non-spared equipment, I repeat once again, is highly critical equipment. We would like to know everything about it and have the entire forecast. If we, for example, take a centrifugal compressor of a reforming unit, it's non-spared. And the turnaround interval we have today is on average 3.8 or 4 years. Of course, we'd like this machine to run without failing for all 4 years. Therefore, now we are facing a task to put a system of predictive diagnostics and predictive analytics that could forecast the state of this equipment. But while there are no such systems, what are we doing? Today we have developed certain procedures that we put this machine out of operation for overall and give it a full overall because our turnaround interval is very long. Secondly, we have developed a system of lubrication system assessment. That is, you have to consider the lubrication system life. Its timely replacement also affects the operation of the rotating equipment. So, at least today, I see that the additional appearance of predictive analysis will give us a better and more accurate health assessment of equipment, at least its residual lifetime. Yes, Vitaly, your experience.
I agree with Alexander, everything is said correctly. The only thing I would like to note is that in our case we have carried out major upgrades. We built new installations and brought new equipment. The requirements for the inter-repair cycle are set by the technical task. The customer said they will work an additional 3 years and the equipment was manufactured for this interval. Now, as far as I understand, we don't know what to do with the Soviet equipment that had a single manufacturing plant, both in Russia and here. At that time, the restrictions was mainly related to the quality of the oil, with the frequency of oil changes, that is, equipment can technically work properly. Yeah, we used vibration measuring cards. Our operators manually measured, recorded, looked at the dynamics of the deviation. But the choke point, let's call it so, was an oil change. Sometime we wrote appeals to the manufacturing plants. Then it was necessary to change the position once a year. We were talking about the compressor. Then the manufacturer agreed the maximum work for 2 years without changing the oil and without stopping. At the same time, we develop our own safety measures, including the quality of the analysis and the quality of the oil, its condition and current operation. I agree with the rest what Alexander said.
Andrei, I'd also like to add, we have already talked about this today. We know very well that the machine lifetime is high enough. But the process engineers, our friends and colleagues, help us all the time. They put the equipment under challenge. It's very important, especially for the non-spared equipment, to follow the process conditions and avoid hydraulic impacts, cavitation, mechanical impurities, and so on. This is very important. Therefore, there must be a clear and strict policy of process conditions. It's required not only for the non-spared machines, but for all equipment in general. Because you know that statistically, 80% of reliability problems are caused by process engineers or process conditions. Absolutely. Therefore, this process moment is very important here. You can make a reinforced concrete compressor, but if its process is challenged at the inlet all the time, it will not withstand certain surges. That's why this is also a very important point which affects the runtime. Thank you, Alexander, for this very important addition. Yes, Vitaly.
I would like to briefly note, but I didn't show it in the main report, that as a part of the implementation project, we had consultants from the USA, from Houston, the professionals with 30 years old of experience. The reliability is based on the approach of the presence of specialists of Six Sigma. We have done a lot of work at each plant. There are now both black and green belts, and what Alexander says about we use these methods and systems for meditat solving. This is the name of the program. We analyze, control, try to reduce the correlation of these operating values when the equipment is more static and the parameters are more smoothly running. The impact on its residual life is less than with fluctuations and pressure drops. Such tools are quite effective.
By the way, Vitaly, here's a question, as I understand, from colleagues at another large oil company. Vitaly, what is the reliability management structure in Kazmunaygas? At refineries, exactly. How many people are there in the reliability department at a refinery?
We've got a director of the Department of Mechanical Integrity Reliability Management at the plant. He controls the procedure according to the structure. There are also Mechanical Integrity Department and the Department of Reliability. The departments are divided by the type of equipment.
Well, how many people in total?
If I'm not mistaken, there are 16 people at the Atarau plant, including the CEO.
It processes 12 million tons, right?
What is the volume of processing?
Yes, it's clear about people. And what is the refinery crude run?
The volume of processing is 5 million. In fact, it's not an indicator here, as is the depth of processing. I spoke with the colleagues from the US and they do not know about such a project at all. It's an indicator from Soviet, probably by the number of pieces of equipment.
By the number of pieces of equipment, I guess.
You know, everything depends on the potential of oil. 300 and high is light oil. Then there is enough primary oil and there are several processes. Targeting at the depth will be greater than when you process low potential oil and you have both cracking and concrete there. Therefore, everything is relative here. It processes 5,500,000 from us. But if we take the Nelson Complexity Index, it's 13.4 because there is also automation and the system there.
All right, next question. Colleagues, this will be the last question because the panelists are tired. They have already worked too much. The last question is for both of you. I suppose it's from foreign colleagues. Do your companies use smartphones or smartphone applications in real time to monitor various production processes and make decisions with the setting of appropriate tasks? Do you use smartphones?
I can answer it. We use smartphones in everyday life.
Exactly, in the company. That's what we're talking about. I mean the smartphones with the specialized applications.
We had phones on which the application is installed, IB Maxima. The mobile solution that I mentioned, we are currently configuring it. That is, each specialist can see the progress status from the comfort of their couch. At the moment, we have such processes as catalyst management. This is more related to technology. They have these solutions implemented on simple smartphone mobiles. Mobile bypasses are a little different. They need specialized devices. And so we are developing IBM Toro and IBM Maxima.
Alexander, yes, thank you, Vitaly. We don't use smartphones today. Right now, we only have pilot tests. The main obstacle in applying smartphones is cybersecurity. Although there are many solutions on the market today, it's very difficult to implement them with cybersecurity in mind. We have strict corporate requirements for that security. We won't circumvent them, because there is a risk. but we are still testing the commercially available solutions. There is no circulation yet, there are only tests so far. Thank you. Well, colleagues, thank you very much once again. At the end of our panel session, I'd like to run a greeting from Sibur, from Maxim, who could not even take part in the roundtable, but recorded the video and sent it to us just a few minutes ago. Let's see what he wished us and move on.
Несколько минут назад сбросил, поэтому давайте посмотрим, что он нам пожелал, и пойдем дальше.
Good day, everyone. I'd like to greet everybody on the behalf of Sibur at this conference on digital reliability of processing plants. And also to say to the colleagues from Dynamics SPC, happy 30th birthday, and to wish them further development, new interesting solutions, and so we, using their solution, could reach safe operation of our production facilities. Thank you very much to all the participants of the second session, and let me introduce the speakers for the final third session of our anniversary conference.
Третьей сессии нашей юбилейной конференции.